This short course gives you a taste of functional programming, showing how it can help you write better, more reliable code by thinking carefully about how you handle data, calculations, and actions. Functional programming is a way of writing computer programs where we focus on using functions to get things done. Think of functions like a machine. You put something in and you get something out. The key idea is that these functions should always give you the same result if you give them the same input. Functional programming is like doing math. Once you solve a problem like 2 plus 2, the answer 4 never changes. The three key concepts: data, calculations, and actions. Data. This is the stuff you work with, like numbers, words, or lists of things. Data exists. It doesn't do anything by itself. Calculations. These machines take data and transform it into something else. For example, adding two numbers is a calculation. It's predictable and safe. If you put the same numbers in, you'll always get the same result. Actions. Actions are where your program interacts with the outside world. This could be saving a file, sending a message, or getting the current time. Actions are trickier because they can have different outcomes depending on when or how they happen. Why we need to separate data, calculations, and actions. Predictability. When you separate calculations from actions, you make your program easier to understand and test. Calculations are predictable, like solving a math problem, so you can focus on them without worrying about outside influences. Simplicity. If you keep your actions separate, you can handle the complexity of dealing with the outside world in one place. This makes your program simpler and more reliable. Reusability. By isolating calculations, you can reuse them in different parts of your program, making your code more efficient and reducing the chance of errors. Example. Let's understand functional programming with an example. User logs into a website. Data in this example is the username and password entered by the user during login. One of the calculations in this example is hashing the password provided by the user. Another calculation is validate the user. Here, hash value stored in the system is compared with the hash value of user entered password. There are two actions in this example. One is to fetch user data. The system looks up the user's information. The second action is returning a response based on whether the password was right or wrong. Let us discuss the algorithm of this in detail. The input data is username and password provided by the user during login. In the fetch data action, the system looks for the record corresponding to the username. Hash the password is a calculation where the system turns the password entered by the user into a hash value. Validate the user is a calculation where the system compares the hashed version of user-entered password with the hashed password stored in its records. Return response is an action where the system tells the user if they logged in successfully or not. Why functional programming is cool. Functional programming helps you write code that is easier to understand, easier to test, and less likely to break. By thinking about data, calculations, and actions separately, you make your code more like solving math problems, predictable and reliable. It's a powerful tool for making sure your programs do exactly what you want them to do, and nothing more. Thank you for watching this video.